Hello, today we're going to look at derivatives of other trig functions. So we already saw how to differentiate sine and cosine, so now we're going to look at the other four functions. What we're going to do is we're going to rewrite these other four functions, tangent, secant, cotangent, in terms of sine and cosine, and then use things like the quotient rule to differentiate them. So we're going to start with tan of x. Tangent is sine over cosine, so that when we differentiate, we'll use the quotient rule, and we'll get that it's the derivative of sine, which is cosine, times v, which is also cosine, minus our original u, sine, times the derivative of cosine, which is negative sine, and then all over cosine squared. And when I clean that up, I get cosine squared x plus sine squared x divided by cosine squared x. Now the really nice thing about cosine squared plus sine squared is that when we go back to the definitions of cosine and sine, and we remember that those involve x over y and x over r and y over r, go back to the actual definitions, we can see that cosine squared plus sine squared is 1. So no matter what x is, if I take cosine of it and I take sine of it and I square those and I add them together, I always get 1. So the derivative of tangent is 1 over cosine squared, which by definition is secant squared. So the derivative of tangent is secant squared. And next we're going to look at secant. And we're going to remember that secant by definition is 1 over cosine of x. And then I'm just going to rewrite that as cosine x to the negative 1. And so I'm going to use the chain rule here. I have a function being raised to a power. So that when I differentiate secant, I bring down the negative 1, raise my function to the negative 2, and then multiply by the derivative of that function. So I get negative cosine of x to the negative 2 times negative sine x. And I can simplify this. I can get rid of the double negative, and then I can bring cosine squared down into the denominator, and then I can simplify it even a little more. And I get secant x tan x, because the sine over cosine squared, if I separate that cosine squared, I'll have 1 over cosine, which is secant, and then sine over cosine, which is tangent. So the derivative of secant is secant tangent. I can do similar things with cosecant and with cotangent, where cosecant would be 1 over sine, and then cotangent would be cosine over sine. And I can just use the chain rule and the quotient rule again. And I get that the derivative of cosecant is negative cosecant cotangent, and the derivative of cotangent is negative cosecant squared. And if you remember, I mentioned before that whenever I differentiate the co-functions, I end up with a negative function. And the non-cos, so the sine, the tangent, the secant are all positive, but cosecant, cotangent, and cosine are all negative. So we're just going to use these in addition to the chain rule and the product rule and the quotient rule in some examples to get used to using them. So for instance, we're going to look at y equals secant squared of 4x. So this will be a double chain rule because I've got 2 compositions in here. So I'm going to first think of it as a function being squared. So I bring down the 2 and then raise my function to the 1. So 2 secant to the 4x. And then I'm going to multiply it by the derivative of secant, which is secant tangent, and my inside is 4x. So secant of 4x, tangent of 4x. And then lastly, I'm going to multiply by the derivative of my inner function, which is 4x. So I get multiplied by 4. And then I'm going to clean it up a little bit. 4 times 2 is 8. Secant times secant is secant squared. So I get 8 secant squared of 4x, tangent 4x. So let's try another one. I've got t times tangent cubed of t. So here I have the product rule, and again inside of that I also have the chain rule. So I'm going to start by doing u prime v. So the derivative of u, which is t in this case, is 1. So 1 times tangent cubed t. plus, and I'm starting the derivative of tangent cubed. So again, this is something being cubed. So I bring down the 3, raise that something, which is tangent, to the 2. And then I'm going to multiply by the derivative of tangent, which, as we said earlier, is secant squared. And then that is v prime. I still need to multiply by u. So I still need to throw in a t there. And again, lastly, I'm just going to clean this up a little bit. I don't need the 1 times, and I'll pull the 3t to the front of my second term. So tangent cubed t plus 3t tangent squared t secant squared t. Let's try now. Y equals 5x secant 5x. So again, I've got a product rule here. So I'm going to start by differentiating 5x and multiply by secant of 5x. So I get 5 secant 5x. And then I'm going to start with v prime. So the derivative of secant of something is secant tangent. That something is 5x. So secant 5x tangent 5x. Then I'm going to multiply by the derivative of my inside function, which is 5. That whole guy is v prime, and then I have to multiply it by u, so it gets multiplied by another 5x. And then again, I'm just going to clean it up. So I get 5 secant of 5x plus 25x secant 5x tangent 5x. They can get a little long, especially with the product rule, but remember, just start doing it function by function inside the chain rule. So as another one, we've got cotangent of 2t divided by 4t. So here we've got the quotient rule. We're going to start by differentiating cotangent of 2t. So that's negative cosecant squared of 2t times the 2, the derivative of the inner function. And then I'm going to multiply by my denominator. So there is u prime v minus v prime u, which is much easier. The derivative of 4t is 4, and then times my original numerator. And then I'm going to divide it by my denominator squared. And again, I'm going to clean it up. So I get negative 8t cosine squared of 2t minus 4 cotangent of 2t all over 16t squared. But I'm not done yet. If I notice, I've got I got an 8, a 4, and a 16. Those all have a 4 in common, so I'm going to cancel a 4 from each of my 3 terms. And I'm going to be left with negative 2t cosecant squared of 2t minus cotangent of 2t divided by 4t squared. So you have to make sure that you're simplifying everything as much as you can. That's the best I can do. I don't have another 2 or a t in this term over here, so I can't simplify those guys. All right, I'm done at this point. That's all I can do. So now we've got y equals the square root of cosecant of 3x. So I've got a function being raised to a power. Remember that this is the same as cosecant to the 1/2 of 3x. Right, the square root is to the power of 1/2. So that when I start and I've got a u to the 1/2, I bring down the 1/2, raise my function to the negative 1/2, and then start multiplying by the derivative of my inside function. So I start by 1/2 cosecant of 3x to the negative 1/2. And then I'm going to multiply by the derivative of cosecant, which is negative cosecant cotangent, still of 3x. And then I multiply by the derivative of 3x, which is 3. Again, I'm going to clean it up. I've got that 1/2, so that 2 can go in the denominator. I've got something to the negative 1/2. That means it's going to go in the denominator. It's also going to be the square root. So that I get in the top negative 3 cosecant 3x cotangent 3x, and in the bottom 2 times the square root of cosecant of 3x. I could simplify this further if I wanted, and the fact that cosecant of 3x divided by the square root of cosecant of 3x is just the square root of cosecant of 3x. So I could actually go further and say this is negative 3/2 cotangent of 3x times the square root of cosecant of 3x. So I could actually even go further than what I had there. But either one's fine. If you don't recognize the fact that I've got a function divided by the square root of itself, that's fine. But now we're going to look at our last example, which again is the product rule. Sine of x times tangent cubed of 2x. I'm going to start with u prime v. So u prime, the derivative of sine, is cosine, and then v is tangent cubed of 2x. And then I'm going to start the v prime. So I'm going to start by looking at my function that's being cubed. So it becomes 3 times that function squared. Then I multiply by the derivative of that function, which is tangent. And the derivative of tangent is, again, secant squared. And then I got to keep going, and I multiply by the derivative of the most inner function, the 2x, which is 2. That whole thing is v prime. Then I'm going to multiply it by u, which was sine of x. And then again, to end it, I'm just going to clean it up. So I get cosine x times tangent cubed of 2x plus 6 sine x tangent squared of 2x secant squared of 2x. Okay, so try out the problems in the book, read through the book, let me know if you have any questions, and good luck.